Nice. Welcome to All Understand Web Learning series. Today we will discuss about 8051 microcontroller pin diagram. The 8051 microcontroller has 40 pins, 20 pins on right side what you observe in the entire 40 pin 8051 microcontroller. Remaining 20 pins are at the other side, that is right hand side. So let us discuss what all are all these 40 pins in one by one. First one is, if you observe here, if you observe from 1 to 8, there is a port 1, that is port 1 8 bits. The first bit is starting from 0, the last bit is ended at 7. So port 1.0 to port 1.7 is the first part of a 8051 microcontroller. That is, you observe that all port of a 1 pins are, that is 8 pins. Now if you observe that these all pins, that is pin number 1 to 8, if you observe that, that is port 0 to port 7. Now these all pins, either port 1 or port 2, port 3, all are IO pins. Now the port 1 importance is it is bidirectional. We can able to connect the input to the port 1 to port 0 to port 1 of a 0 to port 1 of a 7. Nothing but all pins are connected to input, or all pins are maybe connected to the output, or any one of connected to input, the other one is connected to the output. So it is bidirectional. This is the first point you have to remember carefully about the 8051 pin diagram. Now second one is the next port. See the next pin, that is the 9th pin. What is the 9th pin? It is used for the reset signal. If you want to reset the entire microcontroller, we require to activate this RST signal at the pin number 9. So see there, we are going to be use pin number 9, that is reset the entire microcontroller original initial settings. Whatever the user is using different settings when they are using the microcontroller, if you want original initial settings, we can use this pin number 9. Now next one is pin number 10 to 17. Nothing but this is one more port, that is, see there, 1/3 port. See there, if you observe that this is the third port. Every port in a microcontroller has a 8 bits starting from 0 to 7. See there, pin number 10 to 17, there is a 8 pins that is used for, again, all ports in a microcontroller are used for IO pins. Now here the specialty of this port 3 is we are going to be used for almost communication signals, like a receiving signal, transmitting signal. Observe this, receiving signal RxD, transmitting signal TXD, and interrupt controllers. There is a 2 interrupt controllers, INT0, INT1, low active signals. There is a 2 timer signals, T0, T1, and there is a 2 pins for port number 3, that is read write operations. So this is about the pin number 10 to 17, the remaining pins. See there, 18, 19. 18, 19 is the pin number 1819 is provide the entire clock frequency for the operation of a 8051 microcontroller. Observe this, there is a 2 signals, XTL1, XTL2. So this XTL2 and 1, what they will do, they will provide the system clock frequency to operate the 8051 microcontroller. Now the 20 is, it is the low potential power supply, where we are giving the power supply at 40 pin. We require a ground potential that is provided at the pin number 20. So this is about right side all pins. Observe this. Now let us go for in detail. There is one more port, third port, that is named as port number 2. Again we discuss port number 2 initial pin is starting from 21 to 28. All are 8 bit, starting from 0 bit to the 7th bit, highest bit. Now this is used two purpose, it will access, this port is access as a IO as usual the remaining ports are doing. Now the second is it can access the higher order, see the higher order A8 to A15 address. So the 8051 microcontroller, we know that it is a 16-bit for the address bus, whereas data bus 8-bit. So in a 16-bit higher order addresses are starting from where? A8 to A15. This will be accessed by port number 2 in the 8051 microcontroller. Now next one is pin number 29. See there, PSEN. The PSEN is program store enable. If we want to store the program, so we want to enable this PSEN with logic 0 because it is low active signal. So whatever the program we are writing by the user, that will be stored in RAM or EPROM, that can be accessed by low active signal PSEN. See that now, if you can able to provide this EPROM signal, automatically the total program which is stored in EPROM can able to read. That is at a pin number 29. Now pin number 30. What is pin number 30? Already we discussed, we have a address and data bus. Address bus is 16 bus and a data bus is 8-bit. So here we have a pin number 30 to take the address bus and the data bus which is multiplexed in only one bus, nothing but AD bus, address data bus. So to take this address, we require the signal at pin number 30, that is called as address latch enable ALE. That pin is used for, see that, demultiplex the address data bus signal from the AD bus. See there, if you want to set the ALE equals to 1, what happen now? Address can be accessed, address can be decoded, address can be demultiplexed, nothing but address can be accessed, only address. From what? From the AD bus, address data bus line. So this is the importance of the pin number 30 by initiating the ALE. So if you don't want to take this ALE, we can make it active 1, that is then it can access the program code in the EPROM. So it is the thing about the pin number 30. Now pin number 31. What is pin number 31? See there, as like other processors, the microcontroller also can access the external memory, by using the pin number 31. What is the EA? It is the external access. If I can able to set this external access EA 0 low active signal, then automatically EA bar is 1. So the microprocessor is ready to access the external signal. This external signal is starting from the address location of a 000H to the full address length, that is FFFFH. So if I don't want external access, what I can make? I can made EA to be connected to 12 volts. So what happened now? EA bar is 0. So automatically it can be used for the internal access memory. That we know that internal access memory has a RAM. That RAM can be fetched different codes that can be accessed by setting the EA bar is, what is that value? 12 volts, nothing but high potential 1 value. Now next one is, that is pin number 32 to 39, 8 bits again, last port, that is port number 0. So which has IO purpose, input output device can be accessed by this port 0 like other ports, and it has speciality, that is it has a multiplexed AD bus line. What is AD bus line? We discussed just earlier, address data bus. Both are multiplexed. If I want, I can take the address by using the ALE pin enable, and if I want, I can take the data from the address bus by demultiplexed, nothing but decoded from the AD bus. So this is the advantage of a P0 port 0 AD bus multiplexed port. Now the last one, we want entire operation by providing the supply. The supply is provided by the VCC last pin 40 pin. So this is the entire microcontroller 8051 integrated circuit pin diagram, IC pin diagram. So let us, the students can able to think about how to draw these all 40 pins. So I am providing for the student purpose to learn very quickly, to understand how to draw the 8051 all 40 pins. I will give the trick to draw the all pins. How many pins we have, how many ports we have in all 40 pins? We have a 4 ports. Each port has 8 bits. See there, the first port is started from 1 to 8 pins. Now see there, now the second one, leave one simple 1 pin, then start from, that is second port. What is second port? Port number 3. Remember, dear students, please remember that. You remember very clearly, at the right side it is all odd ports, odd numbered ports, 1 3. Automatically right side is even ports, 0 and 2. Like that you can easily write down the all ports. That is how many ports it is? It has a 4 ports. See there, all 4 ports we written. 4 into 8, how many? 32 pins are over at a time. This is a very simple trick to draw the entire. The port 1 and port 3 odd port numbered at the right side, the even port numbered 0 and 2 other what is called as other side. So it is very simple to understand about the all 40 pins, because out of 40 pins 32 pins are very simple. And also the remaining one more interesting point here, port 1 which is numbered, which is not used for any other operation, it is only for IO operation, as remaining ports are IO operation. Along with that, communication and interrupt controller and timer is the port 3, and the remaining higher address bus at port 2 and AD bus multiplexer at port 0. This we can easily write down all 32 pins. Next one is, you observe that one we left now, that is used for the reset. See that, we can use for that what you left, that is reset. Now we observe that the first and most pin, that is 40th pin, starting from your higher potential to lower potential, we are providing the ground. How many terminals are over? 32 plus 2, 34, remaining 6. In the remaining 6, already said that reset is 1 pin, and to operate the entire microcontroller, clock frequency is required, that is 2. How many pins now? 3 pins are over. Now what is the remaining pins? Out of 32 plus 2, 34 plus 3, 37. Remaining how many pins? Remaining 3 pins. These 3 pins are used for memory purpose, our EPROM purpose. See there, you can easily write down all our EP. This is to enable the EP. This is enable the address lines, which is going to be used in the program, and which is going to be used external memory EA. So all these 3 pins are only memory concern pins. So all memory pins are 3. So entire all pins how many? 40 pins. This is a very simple trick to write down the diagram without any mistake in examination. For student point of view, it is very simple thing to write down the 8051 microcontroller to entire all 40 pins. So thank you all.